Hi, this is Pat Gahn, manager of the Ubuntu Server and OpenStack team. Here today on the last day of the Ubuntu Developer Summit, June 2014. And we've got Stefan and Serge here to talk to you about a new super awesome feature that landed in Trusty called user namespaces. And they're going to kind of show you how to use it. And to set the mood for the session, I'll quickly show I'll lock in on Stefan's desktop for a second. Yes, now we feel at peace, and all will go well in the session. So Serge is going to start, so I will just hand it to Serge. And if you have questions, please ask on IRC, and I'll try to raise them as soon as I see them. And I'll try to also ask some of the questions that I think people might have. So Serge, take it away.
Thanks, Pat. Okay, so the topic here is basically user namespaces. Now, the reason for being for user namespaces as far as we're concerned is to allow unprivileged users to safely, securely create containers where they can be root. But user namespaces are not just a LXC feature. They're the core feature in the kernel and some other packages. And so I'm going to start by showing how they integrate into the rest of the system first, and then we'll get into the LXC usage. And actually, the first thing I'd written down to go over is it's not specific to user namespaces, but it'll be needed for the unprivileged LXC usage. So first off, I'm going to talk about the CG manager just for a minute. So C groups are the kernel feature that allows you to group and track and limit resource usage of tasks, and containers use these to track what resources containers are using. Now, when I started this, I've created a fresh VM here, and basically all I've done is install LXC, BZR, GCC, and Make, and then I install the CG Manager utils. Now, if we look at proc self C groups, I'm logged in here, but I'm in the root C group for everything, and that's because CG Manager was not installed when I booted. So I'm going to quickly reboot. And then when I reboot, we'll see that I'm in a set of C groups that I own. It's suddenly so quiet without all that static.
Do you miss it? I muted, so you didn't have to look at the static.
I maybe wonder if I'd gotten dropped. But
No, I'm still here. I was actually making sure that the video was going, because last session I succeeded in not putting the link in. I was feeling a little paranoid.
Okay, so here, is this font big enough for in a screen share? Or need to
I'd make it bigger would be better.
Okay.
Like one more.
One more?
Exactly readable here.
That's fine,
Okay.
fine.
All right, so there we go. So we're in a C group now called user 1000.user 1.session. Now what I'm going to do is mount the memory C group just so I can look at it. And we see that in the root C group, everything's owned by root. I'm going to move on to user. Everything's still owned by root. That's my escape key there. 1000.user, it is still owned by root. So I'm going to go into there. I'm going to bump down there. Hopefully you can still see it, but I want to see more on one screen. So I see that 1.session, my session is owned by me. Everything else here is still owned by root. And if I go inside 1.session, you'll see that almost everything is owned by root, except the directory itself is owned by me, and cgroup.procs and tasks are owned by me. So I can add tasks to the C group, and I can create child C groups, is what that means. So I'm going to, right now, there's plan to write a nicer utility, but right now there's a little script called CGM for talking to the CG manager over dbus. And I'm going to do CGM create memory, and I'm going to, well, let's look here now.
So,
And see that
Serge,
there's
what it just came back with, no,
that's
so that was okay. That was
okay. That was yeah, that's a side effect of the fact that CGM is just a wrapper around a program called dbus send, and that's why I want to write a nicer tool that gives you better feedback.
Is that something you're hoping to do for this cycle?
Time permitting, yes, but it's low priority because CGM does what we need. But it would, yes, I'm hoping to. But so then if we look inside that C group, see all the files now are owned by me. So I'm allowed to set limits now inside the C group that I created. But I'm not allowed to set them in my session. And the reason for that is that systemd or whoever created this, they created one.session for me and shown it to me. And that means that they probably set some limits here that they don't want me to change. They want me to always inherit. And so when I create a child C group, I can change the settings in there because those will be always hierarchically limited to what the parent has. Was there anything else I was going to say about that? Right, so then I can do a sleep, and I can do CGM.
Why are you sleeping?
I'm just creating a task, PID 1099.
Okay.
And we can say proc C group. Tiny keyboard here. See, it's still in my C group, but now I can do CGM move PID memory xxx 1099, and we see that it created a C group. It moved it into that C group there. So that's how, as an unprivileged user, I will be able to create containers and administer its C groups through the CG manager. Okay, so moving on now. There's a program called LXC unshare. There's a version in core util called unshare, which basically does the same stuff with just different syntax, but I'm used to the LXC unshare syntax, so I'm going to use that. It lets you create processes with new namespaces. But as you'll see, I'm not allowed to create most namespaces because I'm still in the init user namespace. As root, I would be able to do that, and now I've got my own mount namespace here, and I can make mounts that aren't reflected on the host. But what I can do without being root is unshare the user namespace. And now if we look at my status...
Right, so now we've got where our process IDs are...
No, process IDs, I haven't done anything with process IDs. I only unshared the user namespace.
Okay.
And since at this point now, my user ID is -1, which is an invalid user ID. I have no capabilities. And if I look at the root, for instance, files are owned by nobody and no group because every valid user ID on the system is not mapped into my namespace. Okay, now this may seem useless at this point, but what happened was that LXC unshare unshared my user namespace, and from that point on, I was user ID nobody, but I had full capabilities towards my namespaces. But then I asked it to execute bin sh, and capabilities are always reevaluated at exec. So what happened was that then my inheritable capabilities were ANDed with the ones of the file bin bash that I executed, which was empty. So I ended up with the empty set of capabilities.
So no capabilities.
Still no capabilities. So when I just do that, basically there's nothing I can do here. I can't go on to unshare other things. I can't create files. There's nothing I can do. But I am ID nobody. So
and the reason you're wanting to... So why are you wanting to unshare, Serge?
I'm wanting to unshare... Technically, it's not what it did was clone, not unshare, but that's beside the point. I want to do that so that I would have a new user namespace.
Okay, that's it. Okay,
so,
cool.
Right, and so this in itself has value if you want to run something that has basically no ability of getting privileges because you don't trust it for whatever reason, and if it doesn't need any file access beyond file descriptors you already have open, that can be useful. But as it is, it's not really useful for unprivileged containers. So now what we're going to do is I'm going to get some code. BCR branch that. And I'm going to compile it all. And in here, there's a couple programs that do a bit more playing with namespaces. Let's see, the first one I was going to do was NSExec. So what this one does, /NSExec. Let's try again, -h. It's kind of like LXC on share, but it's a little more, it does a little more for you. In particular, what we're interested in here is the -U, which is going to do what we did before on share user namespace. And we'll try the, actually, first off, we'll try -S. So
and these are just your little test programs?
Yeah, I've got a couple packages in PPA for them. They used to be, before we had the stuff integrated in LXC, it's how I...
So I guess, are users going to want what you just built?
They're not. I'm just...
Okay, because everyone wants whatever you're showing, probably.
Naturally. Okay, so I'm going to start a tmux in here so that I can split this. What's my escape here? B. Okay. So I'm going to do NSExec-U to unshare my user namespace and -W, which what that does is it did the clone and now is waiting until I hit a key before it's going to do anything more. So now if I look at proc 1210 UID map, it's empty. It unshared a user namespace and it has no UID mappings right now. Whereas my own UID map, huh? How did that happen? Anyway, my own UID map has 0, 0, and yeah, all integers. So 0, the first number is the ID in the namespace. The second number is the ID on the host, and then there comes a range. And so in this task where I'm in the init user namespace, my UID mapping is all container UIDs are mapped to all host UIDs, and that's that. Now I'm not root here, so the only thing I can map is I can map any ID in a container to my own UID on the host. My own UID being 1000, so I'm going to do echo 0 1001 into proc 1210 UID map, and I have to do the same thing for the GIDs. And I'm going to hit a key, and now I'm root. And so what happened was that my mapping was created before I executed bin-sh. So I had a valid user ID.
I'm looking at it again. Okay.
And we're still running with, as we almost always do in Linux, running with the set UID compatibility mode. So that as root, whatever I run, I get my full capabilities. So if I look at proc self status at this point, I've got full capabilities here. Okay. Now from here, I'm root in my own user namespace. However, that's the only namespace I've unshared as yet. So if I try mount-ht proc /proc, that's not allowed because I don't own my own user namespace. So what I want you to do now is, this would be nice under bash. I want to do LXC unshare -s, and I'll do pid and mount bin bash. And that's a CG manager thing, that doesn't matter. What I can do now is mount-ht proc /proc, and now I've got my own PID namespace reflected in /proc. So only 2 tasks show up, 1 and 15, and that's good. Let's see, what else was I going to show here? Okay, are there any questions there about the mappings? That's basically the basis of how everything is done. And so if I look at my proc self UID map at this point, it's 0, 1001, meaning one ID starting at 0 is mapped to 1000 on the host. And you can have more entries, although you have to write them all at once, but you can have more entries than one. But this is how unprivileged containers are done. And so I am root, but on, let's see, let's get back out of this.
Yeah, it gets so many. My mind boggles every once in a while here. I have to kind of.
See, I'm 1228, and so if from here I look at proc 1228 UID map, okay, I guess it'll be the same here, but on a once you start nesting, the values will start being different, and we will see that.
Are we gonna play with that today? Are you, not me, or one of you two?
Stefan's going to show the nesting, or we're going to do nesting. We can do that later.
Yeah.
Okay, so that's that. So now for actually using this in containers. So all I'm allowed to do is map my own user ID. That's all the kernel will allow me to do. So the next concept is not a kernel one, it's with sub-UID. So we have etc sub-UID and sub-GID, which contains a listing of what password considers my authorized sub-UIDs. This means from 100,000, the next 65,536 UIDs I'm allowed to use those. Now the kernel doesn't know about this, and so what we have is user bin new UID map is a setUID root program, which will let me edit my write values to my proc self UID map, limited to what etc sub-UID and etc sub-GID allow. Now using that by hand isn't particularly nice to do, and I basically never do it since I first started playing with it. Instead, what we have is a program called usernSexec, which wraps around that. Now, usernSexec is itself an unprivileged program, not setUID root, but it shells out to new UID map and new GID map to do the actual mappings. And it will look, by default, if I don't say anything else to do, it'll just take my first entry in etc sub-UID and map that. So I'm root here, and my ID map is my default. Now, when you create a new user, as long as it's not a system user, from Trusty onward, by default, it's given the default allocation range. And the reason we do 6,536 values by default is because that way user ID nobody, as known in user space, is mapped, and there are programs that kind of rely on that and end up spitting out failures if you don't have that. Okay, so the way, if you want to modify the UID maps, the UID ranges that are allocated, you can do that using flags to either user add or user mod. And so what I'm going to do is user mod -v and -w specify the let's say 200, 1, 2, 3 to 300, 3 and -w 200. So that's going to be the first one range is the UID range, second one is the GID range that I'm adding to the allowed UID maps for Surge. So now if I look at etc sub-UID, I've got 2 entries there, and I can use when I create a container or when I do anything using new UID map, I can use anything in any of those 2 ranges. Okay, so
Serge,
the way.
So Serge, I'm curious to know. So how do app armor profiles play into any of this?
No.
Okay.
The app armor is a mandatory access control system that's by design orthogonal to all the discretionary access control. And this is all user IDs, which are discretionary access control.
Okay.
Ignoring the capabilities, which are kind of sidestepping both of those. But so AppArmor, whatever we do with the user namespaces, AppArmor is going to keep treating this the same way.
Okay. Okay.
Okay, so in here, there's also a program called, what is it? UID map shift, which in the early days was the way to create. So as you see, when I create a new user namespace and map my UIDs, root is now mapped to a different UID. So if I've created a root file system for my container, I need to shift its UIDs up into the range of my container. And so this program was designed to do that for you. So you can shift all the UIDs in your container so that 0 becomes 100,000, 1 becomes 100,001, et cetera, et cetera. And it just walked the file system tree and did that for you. The thing is, to do that, you have to be root on the host because you have to have all the UIDs in the original map and in the new map mapped into user ID to be allowed to do this. And so it didn't turn out as useful. It wasn't useful for having unprivileged users create their own containers without being root at all. Instead, what we do for the most part is run things like tar and chmod under LXC user NSExec. And so if we look, let's say I touch foo here. See, it's owned by Surge. Now, if I just do LXC user NSExec chown 0 foo, 0 in that user namespace I was allowed to chown to 0 there, but foo was not mapped inside the map, so I wasn't allowed to do the chown. So what we have to do is just, let's see, just so I don't type it wrong, I'll cut and paste from here. Well, that's not good. I'll do it by hand after all. So when you run LXC user NSExec, you can specify an arbitrary number of mappings on the command line, and you do that with a -m flag. When you do that, the first, let's type down B:1:1000:1. What that means is that both B for both UID and GID, so both UID and GID 1 in the container will be mapped to 1000. No, 1 in the container will be mapped to 1000 on the host. And then I want B:0:100,000:1 because 100,000, remember, is allocated to me in Etsy sub-UID. So root in the container will be mapped to 100,000, which is what I want, and 1 in the container will be mapped to 1000, which is my user ID. So I'm going to do bin chown 0 foo. And now you see foo is owned by UID 100,000.
And why did you have to do that versus what you were doing with the chown 0? So why did you have to add all that extra stuff?
Because in order to be allowed to chown from UID 1000 to UID 100,000, both those UIDs had to be mapped into my container. And so I was allowed to map 100,000 because it's my user ID to begin with. And that's the only ID that I personally am allowed to map. And then I was allowed to map 100,000 because new UID map did that for me as set UID root. So then I ended up with user ID in a container where I had foo was owned by UID 1, and I chowned that to UID 0. And then when I exited that user namespace, I got the shifted UID as I wanted. So when you create a container, a lot of this is done behind the scenes. When you do it as a non-root user, a lot of this is done behind the scenes where we do some gymnastics with the mappings to be allowed to chown things into the container. And the other thing we do is that in a tar file, a tar file that's owned by you, we can just read all that under your user ID, and we can extract it under the user IDs mapped into the host. And so we can actually just do an LXC user NX user NSExec as long as we keep mapping your user ID to an otherwise unmapped user ID into container. We can untar any tarball minus devices into your user namespace. And I'm sorry, I ended up much more confusing about that than I wanted to be. Are there any questions?
Let me see. Let me check and see if there's any questions.
Okay. If not, this will all get wrapped up nicely now by Stefan when he shows how to actually do with LXC. So turning it over.
All right. Oh, so give us the. So, Stefan, do you want me to just lock in on your?
Yeah, please look on my laptop.
Yeah, you're just lulling us into.
Yeah. Okay. So yeah, first thing I just want to show how unprivileged containers actually work with
so
LXC.
Here, I'm sorry, but here I'm seeing Stefan and not his screen. Is that?
Yeah,
if you are in the Hangout, you need to actually click on it. Yes.
Okay.
Yeah, you won't see what everyone else. You'll see
Just
whatever.
sure.
You'll see what you want to see, Serge. Everyone else
Thanks.
sees what I want to.
Yeah. Okay. Yeah, that should be big enough. Right. So yeah, unprivileged containers from a user point of view. Starting with 1404, there's not much actually needed to do to get it working. I actually have the nice step-by-step instructions on my blog, which might be easier to follow than looking at my screen at the moment. Basically, there are, as Serge mentioned earlier, there's the main two things to set up is its sub UID and its sub GID, both of which you want to. They will be set up for any new user created, but you might want to check that your user actually has a UID range in there. As you can see, my own user has 65,536 UIDs and GIDs allocated to it. The other thing you probably want to do if you care about having networking running in your container is edit its LXC user net, which basically defines what the user can do with the network interfaces from unprivileged containers. That's actually one of the few bits of LXC that actually set UID to make that thing work. Because even though you own your network namespace in an unprivileged container, you'll probably want to have a point-to-point device to the host namespace so that you can actually get out or to the internet. So that's what we have that file for. It's basically 4 columns. The first one is the username of the user you want to grant some access to. The second one is the device type. The only thing we support at this time is vETH. So that's simple point-to-point device pair. Then the third column is what bridge the user is allowed to bridge into. And the last one is the number of devices that they are allowed to create. So in my example here, my own user is allowed to create 10 devices and bridge them into LXCBR0. So that's basically the only system-wide bits you need to configure as root on your system. All of the C groups are automatically created for you at login time through a change we made into login and some configuration we did. So as you can see, my user is already pre-configured and never had to do anything for that to actually happen for me. Once that's done, one thing you do need to do manually is create a new file called lxc.conf inside .config lxc. That's the equivalent of our global lxc.conf file, which basically, oh, that's the wrong one. Yes. lxc.conf you don't have to care about, actually. You can use it if you want to set alternate container storage location, but you probably don't want to. The one you do need to configure, however, is .config lxc default.conf, which contains the base configuration for any container you create. It's basically based on what you have in the default .conf file for the system side, which contains the network configuration here. So says that all containers I create have one device of type vATH that's bridged into LXCBR0, which is brought up at boot time, and that has a MAC address that's templated, so the X's are replaced at creation time by random digits. The one thing I had to add, however, is my own UID maps. So here I'm defining that UID is 0 in the container, or 0 to 65,536 in the containers are mapped to UID 100,000 to 165,536 on the host. Same thing for the GIDs. On top of that, but that part is completely optional, I'm also by default mapping my own UID and GID to its same value inside the container. That's so I can easily bind mount stuff from my own user outside of the container within the container and not have to care about them showing up as nobody, no group. I've got rather odd GID and UID for my own user on my machine, so that's why you don't see 1000, 1000 as most people would expect. And that's all that's needed. So people doing system, privileged containers are probably used to varlib LXC and varcache LXC. The equivalent paths for unprivileged containers is going to be local share LXC. That's where the containers are stored, and .cache LXC. So that's basically respecting the XDG standard for that kind of thing. Once that's done, you can create containers pretty much as normal. So I can create a container called, say, demo. I don't think I've got one called that yet, so let's do that. Using the download template. So I can say I want it to be Ubuntu. That's why take something I've got locally, maybe. MD64, right. Oh, it actually expired and it's re-downloading. Great. So it may take a little while because it's actually re-downloading the template. But yeah, as you can see, it works the exact same way as it would for system containers. One limitation, however, is that some templates do not work with that. Actually, most templates don't. Because unprivileged containers do things like, can't do things like call mknode, for example. So if you were to try and create something, say, with the standard Ubuntu template called demo1, it's going to tell you this template can be used for unprivileged containers. You may want to try the download template instead. I think at this time, the only templates that actually do work unprivileged are the download template, obviously, because it was designed for it. The Ubuntu Cloud template, which downloads and unpacks existing Ubuntu Cloud images, and the BusyBox template. I think those are the only three that currently work unprivileged. And most people just end up using the download template because it then exports pretty much all of the other images in a way that's usable for unprivileged containers. So yeah, pretty much everything else works in the exact same way. I can list my containers. Let's just tiny screen here, so let's not show the IP information. There. I can enter containers with LXC attached. Pretty much all the commands work as expected. I can even do things like LXC start ephemeral and run that against, which one can I take? Maybe LXC dev. There. So ephemeral containers work just as well, which means we actually got unprivileged overlay file systems working. So if I look at what's the slash for that container in here, where is it? There. We see that I mounted an overlay FS file system as an unprivileged user for that specific container. So that's pretty convenient because that means you can do some of the things that Serge showed on Tuesday, where you can do snapshots and clones of those containers using overlay FS. You can actually do the same thing with BTRFS nowadays, but I don't think we have that in 14.04 yet. That should be part of the next bug fix release. Basically, we initially thought that you couldn't create subvolumes in BTRFS and do snapshots as a regular user, but it turns out you can. So LXC is currently telling you that it's not allowed, and I think we're just dropping that check because clearly it is. So shutting down that container, and yeah, in the meantime, my other container, the demo one, actually got created, so I can attach to it, start it, attach to it, and I can get outside. Now, one thing that might be interesting to look at, if that screen is not too small, is, yeah, it's way too small. So here is a container I just started, so that's the demo container. And you see that we are indeed UID shifted. So looking from the host side, you see that everything is running as user 100,000 or 100,000 plus whatever UID is inside that container. The actual dev nodes are pretty limited as well, because anything that the user actually owns inside /dev in an unprivileged container, they can chmod to whatever they want, and they can access the actual device outside of it. MK node, as we said, as I said earlier, is not allowed, so they can't create something new. Say, yeah, that's just never going to work. But what LXC does is bind mount a few of the entries from the host inside the container. So those show up as nobody, no group. So there's even if I say, even if I had like bind mounted a device that would be risky, I wouldn't be allowed to do something or not. Even time root. So yeah, unprivileged containers are perfectly safe in that regard. They are way safer than our old privileged containers plus AppArmor. And we also use AppArmor for unprivileged containers anyway. So yeah, those you can actually trust. Now, one more cool thing I'm doing with unprivileged containers is actually run GUI applications. For example, the actual Chrome instance I'm running for this Google Hangout is running inside a container. Let's see if I can actually spot it somewhere in there. Yeah, that must be the thing with the giant path here. So, yes. Oh yeah, we don't actually see a weird UID because I actually map my own UID inside for that thing. But if we look, it's running under LXC attach here. So I basically have a few apps in my Unity launcher where rather than starting directly on my machine, they have a wrapper script which starts the LXC container and then attaches inside it and starts the actual application inside there. And it can easily be seen like if I do ls/home of my machine, we see that we've got STRibbon and test in there. If I go in the web browser instead, we just see an Ubuntu directory.
So what are you, so Stefan, I mean, now that you're doing that, do you see is there improvement to performance on your system? Are you seeing any gain by doing this, any benefit?
The main gain is I don't trust those binary tools.
Yeah.
So I can actually run them in an environment where they can't really do much harm because they don't have access to my home directory. They don't have access to anything else. Also, my laptop tends to run a development version of Ubuntu, while those pieces of software are usually developed for long-term support releases. So my container that runs all of them usually runs on a stable release rather than the same release as the host. For example, that specific container is running, I think, 1204 with a 1204 32-bit. So that I don't need to have duplicate installation of all my packages for multi-arch or any of that stuff because the container is just 32-bit 1204 LTS. Okay. And it works really well. I've got the detailed config for that container also on my blog, which explains all the devices.
And you actually have it, so So how did you? So you have details on your blog on how you've made it so actually when you click on the icons from Unity, it's actually
Yeah. So yeah, the actual launchers in Unity. If we go see share applications, I've got say Google Chrome here. That's a copy of the desktop file for Chrome. So I actually have all of the fancy Unity integration with incognito window and all that stuff that actually works. All of the translations and everything. But if you look for the exec commands themselves, they have all been modified so that they instead call into a script, which is called start Chrome. And that script will spawn the precise GUI container, we'll check that it's running, we'll wait for it, we'll do pulse audio socket pass-through inside it, and then does the LXC attach to actually start the command inside the container.
Very nice. So do you have any, I mean, does this make sense as something to push into Unity, or it'd be nice if I didn't have to go and do this myself, Stefan.
Yeah, so
lazy. I just want this feature.
Yeah, it's not exactly trivial at this point, but it's something we're considering as a way to maybe run some Unity 7 or other applications on top of the new Unity 8 system image desktop worlds that we're envisioning. In which case, we would then actually spend the time to get the integration done for containers within, say, Update Manager, so that when you do your updates on your laptop, it also updates any container at the same time, which is currently one tedious thing I've got to do, where I actually have to enter the container by hand and update it, make sure that all packages are in sync and up to date and everything. And then we could possibly also have the software center or whatever we end up using to install packages at that time. Let you choose what container or what system you want to install that thing in, and then just have it show up in Unity. It will definitely be nice, but it's a non-trivial amount of work, and I'm not the right developer for GUI tools.
No, understood. I'm like, wow, this would be great, because I never trust anything, but I don't necessarily want, I am not the right person to go and be messing with my window manager setup.
So currently on my machine, I basically have the policy of not running any binary tool, well, any tool that wasn't built from source by the Ubuntu buildies on my actual machine, and then I just run everything else inside the container. So for example, I can click on Steam here, because being an Ubuntu developer, it means I've got access to quite a bunch of free games from the folks at Valve.
Well, and what I like, this is a great demonstration of how lightweight LXC is.
Yeah, so we see that, I can actually minimize that one maybe.
Are we going to play some games now?
Yeah, so I've got Steam started. I can access my, including the ads for new games.
66% off. You better buy it. Sorry,
So yeah, I can see the game collection I've got. I can then just say, okay, start Team Fortress 2.
So you can claim that playing games in Steam is like part of, you're doing basically QA on.
Yeah.
Wow.
I'm doing QA on LXC. Yeah. So basically the way it works is my container has DevDRI, so the direct rendering interface for the graphic card, by mounted inside it. So it can do raw OpenGL directly to the card. There is no abstraction layer or anything, so it's not like you're running a game in a VM. It's just like you're running it straight on your system.
On the straight system, yeah.
The only reason why it's slow is because it's on a laptop with a crappy graphic card.
Well, it didn't look like what the things you pointed me at. They didn't look like. I mean, it looked like, even though I'm saying, oh, I'm lazy, I don't want to do it, it looks like it's something I could actually do. That's pretty cool.
Yeah, it's pretty simple. The step-by-step instructions are not that difficult. I've done it with for a few colleagues here and there, and it's usually just a few minutes to actually just create the container, install the tools in them, and of the launcher and everything. I think on my blog I actually have the instructions to create the actual launcher and Unity integration and everything.
Well, we might have to just get you to come do a video version of your blog sometime, and you can you can set me up, and we can record it, and it'll be awesome. And then I'll be set up.
CD key authentication invalid. That's special, especially as there is no such thing as a CD key for that game. But okay.
Well, I thought you'd have that sorted because it said you had played today already.
No, I just thought of starting a game like 5 minutes ago, so let's try that one instead. That one should work.
And we've got Scott, Mosier on IRC making little comments here and there. I don't know if I should read any of them.
Is there an actual question in there?
No, it's just comments.
Yeah, Cirrus, I'm not sure. It should work, but not sure whether anyone actually spent the 5 minutes needed to make a template work. I guess it's easy enough to try.
Yeah, and then he said, and no security issues could possibly occur through dev DRI.
Actually, Cirrus had been one of the first templates that did work unprivileged, but that was before I figured out some of the nicer tricks to make it less heavyweight on the templates. So I just haven't taken the time since then.
It can't be used, so yeah, it needs some changes. But it should be pretty trivial because it's already a tarball WIN pack, so it's really, really similar to what we do for the download template, and sure, that one should work. Come on. Yay! It's actually doing something now.
I don't know if Serge plays any of these games because I think that requires him to have a graphics card or something, and he just gets command line things.
Yeah, the answer is no.
Yeah, my laptop is not particularly fast for that kind of stuff, but it's just good enough to start a game, work around a bit, see that it actually works, and yay, that's great.
Yeah.
Then I've got people actually reporting bugs, saying, hey, yeah, you need to bind those extra devices and stuff for fancy high-end NVIDIA or AMD graphic cards. Which I don't have. I just have cheap Intel, but it still works mostly fine.
Well, almost all your people are on the bus or whatever, so there you go.
So, yeah.
Well, very cool. So anything else you guys wanted to... Oh, I got lulled into watching. Anything else you guys want to talk about or cover today?
No, I don't think so. I think basically the main goal for Alexi is to make sure that unprivileged containers are first-class citizens, that all of our standard workloads and tools work with them just as well as they do for privileged containers. Because unprivileged containers are definitely the way forward. That's the only way you can actually trust a container. I mean, our Paramo profile is really good, and as far as I know, nobody actually found a nice way around it to get root access to the host, but it's still possible.
Right, and so if you're already starting unprivileged, well, that user doesn't have any power, so I'm creating this. They're not going to have more power than I have.
Right, yeah, worst case scenario, they just end up being you. There are still fairly frequent user-to-root escalation security issues, but yeah, the worst case scenario is the user will have the same right as the nobody user on your system. And if the nobody user can exploit flows to get root, sure, they'll be able to do that. But then you've got a way bigger problem. And yeah, you have to. So our default containers are default and privileged containers are really safe. And yeah, as Scott pointed out, doing a bind mount of devDRI might not be the best move security-wise, because they get pretty much raw access to your graphic card, and they might be able to lock up your system potentially. But still, your own user actually has access to devDRI, so there again, it's not worse than a regular user. Anything else we should mention, Serge?
I don't think so.
Okay.
And Stefan, where's your blog again? It's stgrabber.
Oh yeah.
stgrabber.org.
Yeah. And I usually have blog posts about Alexei that all refer to each other, so you can pretty much take the link to a series of blog posts here, and then you've got a whole bunch of things. The relevant one here is GUI in containers, which explain step by step how to actually
So
create
that's,
that.
okay, GUI in containers, this is where I can learn to set this up. Okay.
All of the ID maps, the launcher script.
So in Trusty, do I need to do any, is this enabled by default?
Yeah, everything is enabled by default. If you just follow those instructions, it will work.
Okay.
All the systems I'm showing stuff on are standard Trusty with standard Trusty Alexei. There's nothing fancy there.
Cool.
So yeah, currently the blog includes instruction for Chrome with the Google Talk plugin, which is mostly relevant for anyone who wants to do Google Hangouts. Also Skype and Steam. So you also have a launcher here for Skype that how to pretty much just work. Yeah.
Okay. All right. Well, I don't think we have any questions. I think we only have comments by Mr. Smoser. So, thank you very much. It was very, very educational. And have a great rest of your day, Stefan and Serge. Thank you. Bye, guys.
Bye.